Okay, so today we're going to continue talking about modeling and determining the best model given a data set. So first, let's just look if we were doing this by hand, which we could do. We could look at a set of data. Let me create a little graph here. Give myself some tick marks just as an estimate. And I could look at some information that was collected and do my best to determine what model it most closely represents. So if I'm at 1, 1, 2, 3, 4, 5, 0, -1, -3, 5, -1, 3, -2, -1. I do that. So I have 1, 5, 0, -1, -3, 5, -1. Oops, that's one I messed up, right? -1, -3. I knew I messed up one of them. Okay, so I look at my scatter plot. There's my data. And I can see that it's not linear, right? It's not creating a line. And so that leaves me with quadratic and exponential. And if you can see, it's kind of following that U shape where it's going down and then back up. Okay, so I'm going to say that looking at these points, I have quadratic would be the best model to fit that equation. Let's look at one more, and then we'll talk about how we could figure out what equation we could use that would fit that data. So take a moment and plot the points for this second example. And I'll do the same. So 0, 2, -1, 4, 1, 1, 2.5, -2, 8, and 3.25. Okay, so there's my data, a little scatter plot of what I have there. And I would say that that looks like an exponential decay, right? An exponential decay here. So that's great that we can kind of look at the points. We could have also looked at the table and done what we did the other day, right? So this the second difference should be where I could see that relationship, or here I should be able to see a constant ratio if I had looked at my points in the same way we looked at those tables. Okay, but what we want to be able to do is actually find an equation that best fits that data set. So I know that this is quadratic. Well, what quadratic equation would fit this best? Or I know that this is exponential. What would be the function that fits that set of data most closely? Okay, so when we're looking at a scatter plot, if we're looking for linear, right, it's either increasing positive slope or decreasing negative slope. So linear scatter plots are going to look something like that. For a quadratic, it could look like the scatter plot I have there, or it could be have a maximum and go up and come back down. Exponential could be decay, like what we just saw. Could be growth. Okay, so exponential growth, exponential decay. And I'm going to look at the scatter plots and determine, well, which model best fits. And then in my calculator, I'm going to find what's called a regression equation. And so the regression equation, what regression is it's used in statistics to find out what relationship, if any relationship, it could not fit any model, exists between a set of data. And that's really defining what regression is. Regression is looking in statistics, and what relationship exists between these input and outputs. What relationship exists, if any relationship exists between that data. Okay, and we can use our calculator to look at this scatter plot and then determine what's an equation that best fits that data. Okay, whether it's a linear, quadratic, or an exponential equation. So let's look at how we do this. With our page. Now, before we do any of this, I need you to follow along to make sure our calculators are all functioning the same way. So I want you to turn on your calculator. And then, and this isn't, we don't have to do this every time. We're going to do this once and then we're not going to mess with it again. And then at the bottom where it's above 0, see how it says catalog? So I want you to hit second 0. So we go into the catalog of that calculator, and then it's alphabetical. And I want you to scroll down to diagnostics. So go down to D's, and I want to turn the diagnostic on. Okay, so I'm going to hit, when I get down there, I'm going to hit enter on diagnostics on, and I'm going to hit enter again, and it'll say done. So if you need to go back and rewatch that part, make sure you turn your diagnostics on. Okay. Now this calculator work is using a different part of the calculator than what we've used in the past. In the past, we've really been in this gray button area looking at our graphs. Now we want to do some statistics work. We want to look at some data tables and determine our best model. Okay. Now all of this work is under is within the menus that are in this stat menu, statistics. Okay. So in this stat menu, you may just want to watch. Don't press any buttons right now. In the stat menu, there's 3 menus inside of here that I can get to by scrolling left and right. So I have an edit, a menu with edit where I can edit what data set I'm looking at. A calc menu that helps me calculate things. And again, just look right now, don't press any of these buttons. And under calc, I can see lin reg, quad reg, cubic reg, if I go down, quartic reg, lin reg again, ln reg, and exp reg, which is for exponential. Okay, all of those are regression equations. So that's where we're going to be looking when we're trying to find the regression equation. That's what that reg means. Okay, so under calculate is where we can calculate things, and test we won't be using, but you would use in stats. Okay, now, so again, when you're doing this, think of to yourself, well, this is statistics, stat menu. Okay, now in order to calculate things, we need to enter the data in. So we're going to look at this first table that I have here, and we're going to enter the data in. So to enter the data in, we go to stat, edit, L1, L2. Okay, and L1, L2 is going to be where we put in our X and our Y value or whatever they may be called. So I hit stat, okay, and then I'm going to select edit by hitting enter. And what you are going to have here are lists. Now, hopefully your lists start at L1. They should. If not, let me go back to stat, then you may want to click option 5 to have it set it back up. But hopefully yours looks somewhat like this. We have L1, L2, L3, which is just list 1, list 2, list 3. Now, to clear all of your data, okay, to clear what's in there, to clear, go to top of list, and then hit clear down. So let me show you that in here. So just watch and then you can do it. Okay, so if I want to clear this list too, I'm going to go to the top so that it's highlighted. And then I'm going to hit clear down and it's going to clear all of the list. So let me show you on L1. Again, don't do it yet. I go up to the top, L1 selected, I hit clear and down. And now my lists are empty and ready to use. Okay. Go to the top of the list, so it's highlighted. And then we hit clear and down. So if you need to, pause your video, clear out your list. Now we're going to enter our data in here. So on L1, I'm going to enter in my X values, 1, 2, 3, 4. On an L2, I'm going to enter in my Y values, 3, 12, 48, 192. Okay, so copy this table into, once I enter a value, I hit enter to go to the next slot in the list, enter the next value, enter, and keep going. Okay, so these are not, we don't have the equation, so we're not typing anything into Y equals. So the next thing I want to make sure that we do is make sure we clear out Y equals and turn plot 1 on, which means we're going to highlight it. So this step is kind of assuming you understand that piece. So it says turn on stat plot and Y equals highlight plot 1. So we've entered our list in. We want to look and see what this data looks like. Does it look like this? Does it look like this? Or does it look like this? So if I go into Y equals, first thing I want to do is clear out anything that I have in there. So my Y equals should be empty. And then it says turn on plot 1. So I'm going to arrow up. See how it says plot 1, plot 2, plot 3? And I want to turn on plot 1. I want to highlight it so that I see that scatter plot. So I go up, now I'm over plot 1 and I just hit enter. And now when I go back down, see how it's highlighted? So I just went up and hit enter on plot 1. Okay. Now here's a super important button, okay? In order to view our data, no matter where it is, even if it's in the millions, okay, we can use a special zoom function, which is zoom stat, where we'll show the stat plot wherever it is on our graph. So in zoom, you can arrow down or you can just press 9, but you can see 9 is zoom stat. If I hit enter on zoom stat, it's going to automatically make my viewing window to just show the data I just put in. Okay, so that first part is so that I can look at my data and determine which model I have. Okay, so step 4 says observe the shape of the graph and determine a model. So looking at the shape of my graph there, I would determine that I have exponential growth. Can you see the exponential growth there? So I'd say, okay, I have exponential growth, which means that's the regression model that I'm going to select. So this first part from like here to here, this is determining the best model. This is really something different, which is finding the regression equation. Okay, so once I've entered my data, I don't have to turn the plot on anymore because it's already on. Looked at it by hitting zoom 9, I determined that it's exponential. Now I'm really restarting my work and I'm going to find the equation. So it says on step 5, go back into the stat menu, but now we're going to calculate an equation. And we know that we want exponential for this first table. So I'm going to choose, go down to option 0, which is exponential regression, and I'm going to select enter there. Then depending on what model calculator you have, what you have here may look a little different. But essentially I want to enter my way through till I get to the end, and it'll think, and then it will give me this information. So I'm going to let you go. If you need to pause, go back, rewatch that, okay, till you get to here. Now, so we said we have exponential growth, which means we went into our calc menu and we selected 0, which had exponential regression. And then it gave me this information. So it says this, y equals a times b to the x, a equals 0.75. And you don't have to write this every time. I'm just writing it the first time we do it. Okay, that's what my screen looks like. Now, all we're going to do is put these pieces together. So here's my exponential equation. It's telling me that A is 0.75, that my base is 4, and then I have to the x power. So x and y will stay x and y, but it's telling me what to substitute in for A and what to substitute in for B in this exponential function. This equation is the model that best fits that data. So that data is exponential growth, okay, with an initial amount of 0.75. This is telling me the equation that best fits this data. And in fact, it fits it very nicely. These values here, R and R squared, have to do with correlation between how closely does this equation actually correlate to the data that you had collected. Okay, and so for kind of basic, what we're looking for here is the closer to 100% correlation, the better, right? The closer your equation matches your data, the better. And so this is in decimal form, not percentage form. So 1 means it's matching that data 100%, okay? That it's perfect correlation. Great, we know that we have the right model. What I want to show you now, and so don't do this, just kind of listen. So I've gone in, I did stat, calc, I did my exponential regression, and I get my equation, and I plug in A and B to write the equation that matches that table. If I had selected the wrong model, let's say I selected LinReg, which is linear regression, and I go through and I hit enter. Just to show you, do you see how it matches the R squared, and R is lower there because it doesn't match it as well as exponential regression? Okay, if I went in and I said, well, oh, that looks quadratic. If I hit quadratic regression, I might actually fit it okay because I can see, so it actually gives me a pretty good percentage there, 98%. And the reason it can do that is because growth looks like this, right? So they're just assuming it's continuing on the other side. Okay, but I'm looking for the highest R value, the highest correlation I can get. And for the most part, it'll be pretty obvious which model matches it the closest. Okay, let's go through this process again. So go ahead and clear out your calculator. We have another table here. First thing we're going to do is we have to determine the model. So I got to enter my data in and look at it. So in my calculator, I go into stat and I want to edit my lists. Go up to the top and clear those lists out. Remember, you go up so it's highlighted and hit clear down. I wrote that down for you in your notes. In L1, enter all of your X values. And if you have to pause the video because I'm going too fast, do that so that it's going the right speed for you. So I enter all my X values in L1, enter all my Y values in L2. Now we want to look at the data. So I always check Y equals, make sure we're good. It's all cleared out. Plot 1 is highlighted. We're good to go. So now I go zoom 9. Hitting zoom 9 will always reset your window to show where your data is. So there's my data. Observe the shape. So is it linear, exponential, or quadratic? I would say that's linear. Okay, so I looked at my shape and I decided this is linear, which means I'm going to select LinReg in my stats menu. So now that I've looked at that, okay, so I've determined the best model. Once I do that, I kind of start a new process. And this process is all about finding the equation that best fits it. So I go back into stat menu, go over to calc, and this time I want LinReg in option number 4. I enter through however many times your calculator asks you to enter through. And you see how it gives me Y equals AX plus B. And again, we won't write this every time. And it gives me A is 3 and B is -3. And look, my R value is good, 100%. So I know that that's a good model. So I'm taking A and B and I'm just plugging it in. So my model is y equals 3x minus 3. That's the equation, the linear equation, the linear equation that best fits this data table. I've looked at the table, I know it looks linear. Here's the equation that matches it. Okay, let's look at one more. So I go in, restarting on my steps here. I'm not going to go back up to the steps because you have them in front of you. Clear out what you have first, then go into stat, edit. We have to clear this data again. So go up, clear, down, go up, clear, down. Enter in your X and your Y values. Okay. Pause the video if you need to get those entered in. So I have my table here. I'm gonna check my Y equals. Okay, my plot's on. And then hit zoom 9. And there's shows me my data that I just entered in. That looks a little bit like a parabola, right? It went up and it came back down. Not perfectly, but that's what it looks like most. Out of my 3 options, that's what it looks like the most. So it doesn't look exponential, it doesn't continue to grow, it doesn't look linear, doesn't follow a pattern of a line there. So I'm gonna go with quadratic. So, I meant to add in here, option 4 is LinReg. Okay, I believe option 5 is quadratic. So now I have my model, I go back into stat, now I'm starting part 2 of this process, go over to 5, and it's quad reg. It's our quadratic. And in the calc menu, I can see option number 5 is where my quadratic regression is. Enter, enter, enter. So this time there's some rounding. Okay, and my regression isn't that great, but honestly, I don't think, let's try it under stat calc. You don't need to do that. Linear regression, you see how much lower R and R squared are, only matches at 50%. That would be the wrong model to go with. I can see that it looks quadratic. So I'm gonna go with my quadratic model. Okay, so this gives me A, B, and C, those coefficients there. So Y equals AX squared plus BX plus C, that's standard form of a quadratic. And it's giving me an A, B, and a C value to plug in. And usually I tell you what to round to on a word problem. If I don't, just go with what makes sense. Probably 2 decimal places here would be good. So I'm going to plug in A here, rounding as negative 0.54. X squared plus BX, so 3.13, plus C, which is 2.25. And there, I should have done it in red so it matched the other ones, is the quadratic equation that matches this function closely. Okay, and I could even look at it. So another thing that you can do is go back into your Y equals and enter in the equation you just found. Negative 0.54x squared plus 3.13x. It's not going to match it perfectly. And then if I go to my graph, look, here's my points. Here's the equation. And so it's this one that's a little bit far away, right? So that's probably causing that R value to go down a little bit. But they're saying, here's the quadratic, here's the parabola that we feel most closely fits that data, okay? You don't have to do that, just kind of so you can see that link there, okay? So now we've done this a few times. We're going to do this with some applications, which is really